feel like I should feel like I should feel like I should feel like I should feel.
So this is an existing client. He's looking to go for solar panels and potentially a battery. So we're just here to kind of show him the ropes and see what sort of savings he can make. He's already got a heat pump in place, which we put in when was it? About 2 years ago. So he's renovated the house completely, and yeah, so we're here for the next stage. So there's a Mitsubishi PUZ 8.5 kilowatt unit. We installed it 2 years ago now, and it's just been running the house ever since, really. It's doing the heating and the hot water, and quite efficiently, I would imagine.
Yeah, very good.
At the moment, obviously, it's not on because it's nice and sunny, surprisingly, in the UK. But it's probably coming on every morning or every evening for the hot water cycle, I would imagine. 2 years on, and it's going strong. So the way to do it, actually, get rid of the low loss, have it going straight into the heating system, no TRVs on the radiators, all the zones open, and just running it effectively open loop.
Okay.
You get massive efficiency gains that way, and your house doesn't basically fluctuate up and down. Because what you have at the moment, if you have a thermostat, is your house gets up to sort of 21 degrees, it overshoots slightly, then has to go down, it then has to turn the thermostat on effectively, so it loses that temperature, and then you get this happening. Whereas the open loop system, you're using the weather compensation of the heat pump, and the heat pump itself is controlling the flow temperature, so you get a constant temperature in the house, 20 degrees. Okay, so it's on a compensation curve, that's good.
Yeah, Casey said it would be better on that.
Yeah, it would be 100%, because effectively it's, on a day like today it won't need any heating, but even when it's 10 degrees outside, it will still lower your flow temperature, and then as it gets to 0 degrees, it raises your flow temperature slightly to compensate. On the system, I recommend, you just get rid of the TRVs completely.
Oh, really?
That's it, exactly.
Really, there you go, and then...
Yeah, it's because you effectively, they're sized...
But then how can you control this?
So they're kind of sized for each room, because we've done a heat loss on each room, we know what each room needs, and we've sent you the radiator specs for them. So theoretically, what you effectively do is your heat pump, because it's on weather compensation mode, you'll be running the whole house at the same temperature, the flow temperature will be the same, and each room should naturally be around sort of 20 degrees, depending on what we set it. If you want it hotter, you can raise your compensation curve. If you want it cooler, you can lower it. But everything should just sort of stay at 20 degrees, and as you know, when it gets hot like this, the system effectively just shuts off. So the panels are just too big for that, but we can put one in landscape just over here.
Okay. If we didn't, we'd obviously have to go up the
top. The other roof we can fit 13 panels. Some people don't like the flat roof looking panels, but then some people, you never really see it.
And on something like this, do we need planning?
No, you won't need planning for this because, you've never really needed planning for these unless you're in a conservation area.
Right.
With anything with panels, you have to think of payback. You've got a payback chart here. With the 14 panels that you have now, your sort of payback period happens at year 6. Right. So it just depends really on how much you're willing to wait for it, really. And the system that we use with microinverters. So these here. So microinverters, we use N-phase a lot because especially in shady conditions or where you've got one panel there, you could never really stick one panel on a big inverter. It's just it's not going to have enough voltage to even turn it on. So you've got microinverters that sit behind the panels, and they effectively optimize each panel, and they produce your AC directly from the panel. Okay. They come with a 25-year warranty. So they're pretty bulletproof, and your panel comes with a 30-year warranty. Because we've got smart tariffs available to us, you can actually put in oversized batteries, charge them during cheap times, and then use that electricity. So Octopus Cozy is a really good example of that.
Okay. So I'm with Octopus anyway.
So what we do is look at your winter usage, which you'll have now with the heat pump. Say you're 40 kilowatt hours a day, you put in something like a 13.5 kilowatt hour battery. You charge it those 3 times of the day, and during those cheaper times, you're effectively using that battery. And it's 13 pence per kilowatt hour versus
26 or whatever it is.
That's it. What you find with the battery normally is it increases your payback slightly, but then your overall yield is actually higher. Right. But this doesn't take into account the tariff you're using, so it's something we can play with the numbers a little bit to give you an accurate sort of representation. But usually they are worth it. It just comes down to sizing it correctly, and we don't want to size it too much to where you don't even use it, because then you'll be coming back to me next year saying, why have you sold me such a good battery? What I would probably say, if you didn't want it to look, I like things looking really nice and neat. I just tried to fit as many as I could on to give you an idea. you could probably get rid of those 3, and then you've got a nice sort of L there. You know, it's usually a good idea to try fit as many as you can on, because you will benefit from it, but it won't cover 100% of your demand. That's the only thing.
No.
But
I presume obviously winter it's a slightly different.
Yeah, winter. That's the problem, because you've got the heat pump running. You don't have very much sun, but you want the power. That's where the Octopus tariff comes into play, or any tariff really. You can then charge that battery and use that instead. Sure. And in the summer, when you've got loads of generation, you can then charge your battery with the panels, because then your heat pump's not on, is it? So, what I'd normally say is charge your battery up as much as possible. At the end of the day, use your battery to then do a hot water cylinder charge, to try use that energy, because you want to try and use it when you can.
Does it then automatically switch over to the battery, or do you have to then tell it?
It will do, yeah. So it's your battery system's very clever. It kind of looks at whatever the demands are. If it sees your panels are generating, your house is using from the panels, it will just leave it alone. Okay. It knows if your panels aren't generating and you're using it, automatically come from the battery. You don't have to tell it to do anything. We installed Tesla, Sig Energy is another one. They're quite popular. We used to install a lot of Give Energy, but we're trying to keep with the latest technology. There's also PowerVolt as well. They use AI systems. There's loads of different options really. Try to choose the option that's
and how
good
much,
with the budget.
How big is a typical battery?
Probably would allow, probably around sort of 1 meter wide, 1 meter tall, about 200 depth, that sort of thing. So it could probably even go, depending on what this load calc reveals, because I know how many meters that is to your fuse board. We can see how much power the battery can output, because that's the customizability on it. You can also choose how much power output you want to go to the house at any one time. So your heat pump's going to be using 2 kilowatts. You might be using your induction hobs. That's another 2 kilowatts potentially. So you can choose. Okay, I want to do 6 kilowatts to the house, and I can make sure the cable's all right. If it's not, then we have to choose another place for the battery. But in terms of battery location, the back of there would be perfect. Or somewhere north facing ideally, because you don't want the sun roasting it all day.
No, sure.
But somewhere around it where your heat pump is probably would be a good shout as well. Another point on the batteries as well is, as I said, they're customizable on how much output you want out of them, but they're also customizable in storage capacity. Right. So if you say, okay, let's do a 10 kilowatt system now, in a year's time we monitor the data, you go, actually we could do with a bit more. We could come back, take the head of the unit off, put a 5 kilowatt expansion on, put the head back on. That's it, you're good to go. We recommission it, but and then you've got a 15 kilowatt hour system, so it's very customizable. I predict you should be doing around 6,200 kilowatt hours, probably less without that panel, but then more with those ones on. So it gives you an idea on your savings, because if you could use all of that, you times that by 27 pence per kilowatt hour, that gives you your sort of savings, and that should be around £2,000 a year if you use everything. That's the trick. It's very hard to use everything, but you do get paid by the grid as well if you do export, and that's all. If you have a smart meter, it's all sort of automated. Sure. And then your cost year, which this is for 14, would be 13. As I said, when you put all the payback analysis into it, you sort of see where you're. I'll leave this with you so you can have a good read.
Have a look.
Bit of bedtime reading.
I can't wait. No. Thank you very much. That's great.
All right. And I'll re-edit the report, and I'll include that as well. Only thing I'd ask is if you could find out what sort of thickness joists you're using up there. Okay. Just because I need to know how many panels we can safely put on without buckling the system. From a structural sort of point of view.
Have you got rough weights of the panels you're going to put on?
Yep, so the panels themselves are about 23 kilograms. The ballast, it really changes depending on quite a few things, but if you allow sort of 60 to 80 kilograms per panel as a rough rule of thumb, that's ballast and the panel and the frame, then you shouldn't be too far off.
Okay.
Alright, any questions?
No, I think that's very good.
Once I start talking, it's hard to stop me.
No. I probably will come back with some questions.
That's fine.
That's brilliant. Thank you very much.
Yeah, no worries.